Hello students, hello viewers, welcome to Senior College Mathematics. Topic of discussion is modular arithmetic. If you are in senior college, you are preparing for WAEC, for NECO, for GC, for NAPTEP, for JAMB, or any other external or entrance examinations into high school, this lesson is for you. Lesson 4, multiplication and division in modular arithmetic. So let's take multiplication. Multiplication of modular numbers involve successive repeated additions. That is one way of doing it, or you use multiplication table of the given modulus. So for instance, we have 3 times 6 modulus 7. This means 6 plus 6 plus 6 modulus 7, and when you add, you have 18. In modulus 7, 18 is not an element. If you divide 18 by 7, you have 2 remainder 4. This is the 4 that you have here. So 18 modulus 7 implies 4 modulo 7. The multiplication table for modulus 7 explains better. So this is the table. Notice that modulus 7 has 7 elements from 0 to 6. So you arrange them row and column. You use the first element in the row to multiply all the elements in the column. You have 0, 0, 0 all through. If you use the second element in the row times each element in the column, you have 0, 1, 2, 3, 4, 5, 6. Let's take the last element, 6, in the row times each element in the column. 6 times 0 is 0. 6 times 1 is 6. 6 times 2 is 5. This is what happened. 6 times 2 is 12. In modulus 7, if you divide 12 by 7, you have 1 remainder 5. So you keep the remainder 5. 6 times 3, you have 4. 4 is the remainder. 6 times 4, you have 3. 3 is a remainder. 6 times 5, you have 2. 2 is a remainder. And 6 times 6 is 1. This is what happened. 6 times 6 is 36. Divide by 7, you have 5 remainder 1. So let's check 3 times 6 now. So this is 3 and this is 6. Their point of intersection is 4. So you have 3 times 6 in modulus 7 is equal to 4. Hello. You can use the table approach or the multiple approach. So examples, simplify the following. 6 times 9 modulo 6. Okay, so 6 times 9 is equal to 54. So here you look for a multiple of 6 that is close to 54. In this case, 54 is a multiple of 6. The number that 6 should multiply to give 54 is 9. So you have 9 times 6, 54. So you just need to add remainder 0 because remainder is what we are interested in. For that reason, 6 times 9 modulo 6 is equal to 0 modulo 6. Example 27, we have 50 times 29 modulo 15. So you multiply the numbers together. 50 times 29, you have 1450. So in terms of multiple, the multiple of 15 that is close to 1450 is 1440. The number that 15 should multiply to give 1140 is 96. So 96 times 15 is 1140. You need to add 10 to get 1150. So that 10 is the remainder. Therefore, 50 times 29 modulo 15 is 10 modulo 15. Hello. Example 27. Simplify 5 bracket open 6s plus 2 bracket close modulo 7. So we expand the number first by using 5 to open the bracket, where you have 30s plus 10. 5 times 6s is 30s. 5 times plus 2, you have plus 10. We can attach modulo 7 to each number and work out the remainder. So you have 30s modulo 7 plus 10 modulo 7. So in terms of multiple, we look for the close multiple of 7 to 30s, that is 28s. The number that 7 should multiply to get 28s is 4s times 7. You need to add remainder of 2s to it. For 10, the close multiple of 7 to 10 is 7. The number that 7 should multiply to give that multiple is 7. Hence, you have 1 times 7 is 7. To get 10, you need to add remainder 3. So therefore, 5 bracket open, 6s plus 2 bracket close, modulo 7 is equal to, we are interested in the remainder, that is 2s plus 3. 2s plus 3, what do you have? 2s plus 3 modulo 7. That is the remainder from both numbers. 2s, then 3. 2s plus 3 modulo 7. Hello. Example 28. You have bracket open, 3s minus 1 bracket close, another bracket open, 5s plus 4 bracket close, modulo 6. What we do first is to expand the bracket. So when expanding, you take the first term 3s in the first bracket to multiply the two terms in the second bracket. So 3s times 5s, you have 15s squared. 3s times plus 4, you have plus 12s. You take minus 1 to multiply 5s, you have minus 5s. The same minus 1 times plus 4, you have minus 4. These two like terms, when added together, you have 15s squared plus 7s minus 4. So let's attach to each number the modulo 6, then work out the remainder. Remember, the remainder is the answer. So you have 15s squared modulo 6 plus 7s modulo 6 minus 4 modulo 6. In terms of multiple, that multiple of 6 that is close to 15 6s squared is 12s squared. To get that 12s squared, you have to multiply 6 by 2s squared in this form. The remainder that need to be added to get 15s squared is 3s squared. When you move to 7s, you have 1s times 6, remainder s. When you move to minus 4, although 4 is an element in modulus 6, but minus 4 is not an element. So you need to add minus 4 to modulus 6, and that will give you 2. So bracket open, 3s minus 1, bracket close, another bracket open, 5s plus 4, bracket close, modulus 6 is equal to 3s squared, that is the first remainder, plus s, the second remainder, plus 2, the third remainder, modulo 6. Hello. So let's look at division. Division is the inverse operation to multiplication. Given any elements p and q, there exists a unique number, a unique element c modulo arrow, such that p divided by q is equal to c modulo arrow. Now this is what happens if you divide p by q under the given modulo. You are going to have remainder c. This c is what you look for in division of numbers in modular arithmetic. This principle aids in the division of modular numbers. If p divided by q is equal to c modulo arrow, for us to clear the fractions, we need to multiply c by q. So this expression also implies p equal to q times c. You have modulo arrow. So we take examples to explain how you can get that c, which is the remainder and the answer that is needed. Examples: number 29, divide 9 by 8 modulo 11. This is what happened. We have two methods. Method 1 is you carry out multiplication on 8. You are multiplying 9 by 8. So the second number 8, you carry out multiplication on 8 in modulo 11. That is using digit from 0 to 10, and you note the remainder. The one that gives this 9 is the result. So you have 8 times 1 is equal to 8 modulo 11. 8 times 2, you have 5 in modulo 11. 8 times 3, you have 2 in modulo 11, and so on. Now let's go to 8 times 8 is equal to 9 modulo 11. 8 times 9 is 6 modulo 11. 8 times 10 is 3 modulo 11. Let's explain the last one. You know, 8 times 10 is 80. In modulo 11, 80 is not an element. So you divide 80 by 11 and you have 7 remainder 3. That is the 3 you have there. If you check out the multiplication, the one that gives 9 is 8 times 8 equal to 9 modulo 11. So therefore, if you divide 9 have 9 modulo 11. This is one of the methods of dividing numbers in modular arithmetic. Verification of example 29 using method 2. That example is divide 9 by 8 modulo 11. So you let 9 divided by 8 equal to C. C is the unique element, that is the remainder in modulo 11. So you need to get C. So what we do is that we equate 9 divided by 8 equal to C, the remainder, and when you clear the fractions, that is multiply through by 8, you have 9 equal to 8C. This is what happened. Add 9 to the multiple of 11 that can be divided by 8. You list the multiple of the modulo 11, then you look at them, the one you can divide by 8 after adding 9. The first multiple of 11 is 11. If you add 8, you cannot divide it by 9. The second one is 22. If you add 8, 9 cannot divide. The third one is 33. If you add 9, if you add 9, you are adding 9. 8 cannot divide. If you add 9 to the next one, 44, 8 cannot divide. And you have 55 plus 9. That is 59 plus 9 is 64, and 8 can divide 64. So what you do is to add the number at the left to the multiple of the modulo and check each stage of addition. Can 8 divide? And we find out that it is at 55, the multiple of 11 plus 9, that 8 can divide. So you add 55 to 9. So we have 9 plus 55 equal to 8C. And you have 64 equal to 8C. Divide both sides by 8. C is equal to 64 divided by 8, and you have 8. So therefore 9 divided by 8 is equal to 8 modulo 11. When we solve using the first approach, we have 9. Now we are having 8. Both answers are correct because 8 and 9 are elements in modulo 11. Hello. Example 30. 3 divide by 5 modulo 6. By the second method, you let 3 divide by 5 equal to C, that unique element in modulo 6. So we have 3 over 5 equal to C, which implies 3 is equal to 5C. This is what happens next. You add 3 to the multiple of 6 that can be divided by 5. 5 is the coefficient of C. You know, we are interested in positive integer. Integer is a set of negative and positive whole number. But here, what we want is the positive whole number. Okay, so that is about that. All right, so we add 3 to the multiple of 6 that can be divided by 5. 6 is the modulo, so you have the first multiple of 6 is 6. If you add 3, that is 9. 5 cannot divide. When you go on in that order, you see that the multiple of 6 that you will add 3 to that 5 can divide is 12. So you add 12 to 3, that is 3 plus 12 equal to 5c. You have 15 equal to 5c. Divide both sides by 5 in this form, and you have c equal to 3. Therefore, 3 divided by 5 modulo 6 is equal to 3 modulo 6. Example 31. You have 2 cube divided by 3 square modulo 5. 2 cube is equal to 8. 8 is not an element in modulo 5. If you divide 8 by 5, you have 3 modulo 5. 3 square is equal to 9. 9 is not an element in modulo 5. If you divide 9 by 5, you have 4 modulo 5. So the problem is 3 divided by 4 modulo 5. So let 3 divided by 4 equal to 6, the unique element that we must look for in modulo 5. So if you convert this from division sign, division line, you have 3 over 4 equal to c, which implies 3 equal to 4c. You look for a multiple of 5 that you can add 3 to that 4 can divide. Multiple of 5 that you can divide by 4 after adding 3, and that is 5, the first multiple. 5 plus 3 is 8. 4 can divide 8. So you have 3 plus 5 equal to 4c. That is 8 equal to 4c. Divide both sides by 4 in this manner, and you have c equal to 2. Therefore, 2 cube divided by 3 square modulo 5 is equal to 2 modulo 5. Example 32. We have 3 times 2 in bracket divide by 5 modulo 7. By the rule of Bodmans, you need to simplify the terms in the bracket first. That is 3 times 2 equal to 6. So you have 6 divided by 5 modulo 7. This is what happened. So if you express 6 over 5 and equate it to c at the end, you are going to have 6 equal to 5c. So you look for a multiple of 7 that you can add 6 to that 5 can divide. Multiple of 7 that you need to add 6 to that 5 can divide. That multiple is 14. So you have 6 plus 14 divided by 5 modulo 7. So we have 6 plus 14 is 20 divided by 5 modulo 7, and that is 4 modulo 7. Hello. End of lesson 4. Thanks for watching and learning. Don't forget, watch out for more from the voice of Petakus. Lastly, if you are not safe, your life is in crisis, to avoid that, you give your life to the one that can save you, and that is the Lord Jesus Christ, and you confess him as your Lord and personal Savior every day of your life. If you are saved already, congratulations. Live righteously, and be prepared, because on the last day some will be taken and some will be left. Take good care of yourself. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Use your hands and your brain to work genuinely and legally, and the Lord will bless you. Goodbye.